Hi everyone and welcome back to my channel. In this video, I'll explain the roots or radicals. We will see together what is the square root of 4, what's the fourth root of negative 81 if it is possible, the square root of x squared, and sometimes we use the square root or the nth root as a to the power 1 over n. What are the roots or radicals? They are the inverse operation of exponentiation. The most well-known roots are the square root and the cube root. What's the square root? It is a root of degree 2. And it's written in the form square root of a. So no need to write number 2 to specify the degree of the root. Now what's the cube root? It's a root of degree 3. And it is written in the form cube root of a. Examples. Now we know that the first example is the square root. It is the root of degree 2 of the number 4. Now what's the answer here? In order to answer this question, you have to ask yourself, what is the number if I multiply by itself 2 times, because the degree here is equal to 2, it will give us 4. The answer is 2, because 2 times 2 is equal 4. Again, what is the square root of 4? Ask yourself, what's the number if we multiply by itself 2 times will give us 4? The answer is 2. Second example, ask yourself the same question in case of trying to find the square root of 25. What is the number if we multiply by itself 2 times will give us 25? We know that the answer is 5, because 5 times 5 is equal 25. So we need the answer to be what is under the root or the radical. Now, what is the square root of negative 4? Ask yourself, what is the number that we multiply together by itself 2 times and will give us negative 4? Let's try. We know that 2 times 2 is equal 4. And negative 2 times negative 2 is equal to 4 also. So there is no number. The only thing that we can get negative 4 is to multiply negative 2 by 2 or 2 by negative 2. But we need to multiply the number with itself, having the same sign. So in this case, the square root of negative 4 is undefined. It's only undefined over the system of real numbers. In case of having complex numbers, yes, we do have an answer that's 2i. Now, what is the cube root of 8? Now ask yourself, what is the number if we multiply by itself 3 times will give us 8? The answer actually 2. Why? Because 2 times 2 times 2 is equal 8. So what's the number if we multiply by itself 3 times will give us 8? The answer is 2. The cube root of negative 8. Ask yourself, what is the number if I multiply by itself 3 times will give us negative 8? I assume that the answer is negative 2. And let's see together. Negative 2 times negative 2 times negative 2 times negative 2. We know that negative times negative is positive, and positive times negative will give us negative. 2 times 2 is 4 times 2 is 8. So multiplying negative 2 by itself 3 times gave us negative 8. So the cube root of -8 is equal -2. Example number 6. What is the square root of 81? Ask yourself, what's the number if we multiply by itself? 2 times will give us 81. The answer is 9, because 9 times 9 is equal to 81. Example number 7. What is the square root of -81? Now ask yourself, what's the number if we multiply by itself? 2 times will give us -8. There's no way to be 9, because 9 times 9 is 81. What about -9? -9 times -9. Negative times negative is positive, and the answer is 81 again. So again here, the answer is undefined. Again, example, I can't call this 7 prime. It's the fourth root of 81. Now, or let me call this number 8 prime, and this is number 8. What is the fourth root of 81? What's the number that we multiply by itself? 4 times will give us 81. I assume that the answer is 3. Let's try. 3 times 3 times 3 times 3. This is 9, and this is 9. 9 times 9 is 81. So the answer is 3. And for question number 8, the fourth root of -81. Now ask yourself, what's the number if we multiply by itself 4 times? The answer is -81. Now there is no way to be 3. What about -3? Negative and negative will give us positive. Negative and negative will give us positive. The answer is positive 81. So this one again is undefined. This will lead us to the following rule. I wanted to focus on example number 5, 6, 7, 7 prime, or 8 prime and 8. Did you notice anything? If we have the nth root and the degree here is even, and what is inside the square, the root is positive, then the answer is, it is defined. It's defined. And this is as in case of what? Of 81 and 81 again, with the square, or the degree number 2 and the degree number 4. Now, if it is even with negative, as in the case of number 7 and number 8, we have 2 even and we have 4 even. But what is inside the root is -81. So the answer is directly undefined. In case of odd, whether it was positive or negative, the answer is defined. So the only case that we have for undefined result, in the case of dealing with real numbers only, is when we have an even degree and we need the root of a negative number. This is the only case, as we saw in example number 7 and example number 8. They are undefined in case of having 2 and 4 even degrees, and the number is -81. So directly, the answer should be undefined. There is no way to multiply a number by itself even number of times and get a negative result. In case of odd, we don't have a problem. Whether it was positive or negative, the answer is defined. And I'll tell you one thing. If it is positive in case of positive, and it is negative in case of it is negative. And in case of having even with positive, the answer is only positive. Let's have some more examples. Now, let's go to the rule. The nth root of a is actually can be written in a different way. It is a to the power 1 over n. I'll give you a simple example. We know that the square root, the degree here is equal to 2. The square root of 4, we want only to simplify. We don't want to evaluate. So this one is exactly as 4, if we use this rule, to the power, flip this number. It is 2, so it's going to be 1 over 2. What about this example? Now we will do 2 to the power 2. What is inside the root is 2 to the power 2. We know that the degree here is equal to 2. So all of this to the power 1 over 2. But we know if we have an exponent raised to another exponent, what we should do, we should multiply the exponents. So it's 2 to the power 2 times 1/2. The answer is, this one is equal to 1. So it's 2 to the power 1, which is equal to be 2. The following example number 3, the square root of -2 square. Now you might ask the following question. This is directly undefined. But this is not true. Be careful. If the question was like this, in this case, this is true. This is undefined. But let's simplify it. This is actually the same as -2 to the power 2. Anything, this is true, that is a negative number to an even number. So the answer should be even. It should be positive, sorry. So we know that -2 to the power 2, -2 times -2, the answer is 4. So this is 4 to the power 1/2, which is equal to be 2. Now what about the cube root of -27 to the power 3? This will be -27 to the power 3, all of this to the power, flip this, 1/3. We know that 3 times 1/3, anything multiplied by the reciprocal of the same number, the answer is equal to be 1. So the answer is -27. You might ask again, why I didn't do the same thing here? It's true. I didn't use the same thing. I can, let me explain this. Why I didn't say -2 to the power 2, all of this to the power 1/2. Cancel this, like 2 times 1 over 2. The answer is -2 in this case. But this is not true. Why? Because this 2 is an even number. First of all, even number will change this to be positive. So as if it is positive. Negative number is not allowed with even roots. Let me give you more examples. Let's apply this on the variables. I'm sure that a lot of times you saw this. The square root of x squared, the answer is absolute value of x. Why is this? Do you remember the example that I just explained? -2 square. What I said, I said it's negative 2 to the power 2, all of this to the power 1/2. The first method that I used, I said negative 2 to the power 2 is 4, and it's 4 to the power 1/2. And we know that 4 to the power 1/2, or the square root of 4, is equal to 2. Or I have to say this 2 will change this to be a positive number. And then we can multiply 2 times 1/2. So I'll change this to be 2, and then I have to say 2 times 1/2, and the answer is 2 to the power 1, which is equal to be 2. That's why, in case of having an even, doesn't matter if it is 2 or anything else, like 2 or 4 or anything, and you want to cancel this with this, first of all, you have to put the square root, the absolute value. So here, I can do it from the beginning. It is equal, cancel 2 with this 2. It's the absolute value of negative 2, and the absolute value of negative 2 is equal to 2. So in order to guarantee that the answer is defined, you should put an absolute value, only in case of dealing with even degrees to the roots. Look at the following. This one, we can cancel this or this, and the answer is x. And to show this, it's x to the power 3, all of this to the power 1/3, which is x to the power 3 times 1/3, and the answer is equal to 1 here, so it's x to the power 1, which is equal to be x. So if you have an odd number, the degree is odd, and it is the same as the exponent to the x, the answer is x. But in case of dealing with even, if it is even here, and this is the same number, then put an absolute value. So what do we expect here? X to the power 4, we need the fourth root. It's directly equal to the absolute value of x. What about here? Be careful. X to the power 4 and 2, they are different. So what should I do? I have to say x to the power 2, all of this to the power 1/2. So I have to multiply 4 times 1/2. So it's x to the power 4 times 1/2, which is x to the power 4 times 1/2 is equal to, so the answer is x squared. What if we have the converse? The 4 is the degree, and the 2 is the exponent. Again, it's x to the power 2, all of this to the power 1/4, which is x to the power 2 times 1/4. We know that 2 times 1/4 is equal 1/2. So it's x to the power 1/2. But we know that x to the power 1/2 is what? Is the square root of x. Because it's, if you flip this 2, it will be x to the power 1/2. Example number 10. The sixth root of x to the power 4. So we can write it as x to the power 4, all of this raised to the power 1/6. And then we need to multiply 4, because a power to another power, 4 times 1/6. The answer is x to the power 4 times 1/6 is 4/6. Now, we can divide here by 2 and get 2, and divide by 2 and get 3. So it's x to the power 2/3. I claim that this one is equal to x to the power 2, all of this raised to the power 1/3. If we multiply 2 times 1/3, the answer is 2/3. But we know that this will give us the root. So it's the third root, or the cube root. And what is inside the bracket is x squared. Number 11, we have a bracket. all of the bracket raised to the exponent number 3 or exponent 3, and it's a cube root. We know this will be cancelled with this. We have no problem because at the end 3 is what? An odd number. So the answer should be x plus y. But in case of 4 and 4, this is even. They will be cancelled, but we need the absolute value of what is inside the bracket, which is x plus y. Example number 13, and be careful here. I've seen a lot of students do the following. Either they do, the answer is the absolute value of x plus y, because it's here too. So they cancel. And some of them, they do the following, the absolute value of x plus the absolute value of y. And actually both answers are wrong. If we have the exponent is raised to each variable separately, and there is a positive or negative sign between them, so we can't do any more simplifications. So the answer is the same, which is the square root of x squared plus y squared. If there is a multiplication as in example number 14, in this case, yes, the root can be distributed. So we can do the following, the square root of x squared times the square root of y squared. In this case, yes, we can cancel here and here, and here and here. The answer should be absolute value of x, and the answer here should be absolute value of y. And the absolute value can be written as an absolute value of x, y. And I can show you another way how to do this. The square root of x squared times y squared, we know that this can be written, x squared times y squared can be written as x times y squared. So if we cancel this with this, what is inside the bracket is xy, or x times y, xy. And we need, because we have an even degree, we need an absolute value. See, the answer here is exactly as here. Please like and share the video. Please also subscribe in the channel. Thanks for watching.